All right. Again, thank you, Izzati, for sharing your answer. Right. Now I'm presenting the question first. Okay. Okay. Can you see the PDF file that I displaying over here? See,
Can.
Yes, okay.
not big enough. Okay. This, I think this is better. All right. Basically, the question, this is a tutorial for this week, and you need to submit it on Sunday, by Sunday lah, 11:59 p.m. Through e-learning. The objective of we discussing the question today is to for you to identify your mistake, and later on you can submit the correct one through the e-learning link. All right. For question number 1, looking at the question, it says here, in the circuit shown, the resistor value are given by R1 1000, R2 1000, and V, the DC voltage source, equals to 20 volts. The voltage across AB, i.e. across R2, is measured by a voltmeter whose internal resistance is given by Rm equals to 9,000 or 9.5 kilo ohm. The first question, A, what will be the reading on the voltmeter? And for B, what would the voltage across AB be if the voltmeter was not loading the circuit, i.e. if Rm equals to infinity? And the last question is, what is the measurement error due to the loading effect of the voltmeter? Okay. Basically, this is a question which is, I think, similar with the one that you saw in our lecture notes, except that the circuit is a little bit simpler. If you look at the circuit, we have two resistors connected in series, and I think within a second we can determine what is the voltage across R2, since we have been given the voltage, the resistors value R1 and R2, both R1 and R2, and I think by manual calculation or by theoretical calculation, the theoretical solution, we try to use voltage divider rule over here to get what is the voltage across R2. Okay, and Izzati, can you answer my question, my actually preliminary question? If you want to calculate R2, voltage across R2, what is the voltage over here in manual calculation using voltage divider rule? What is the voltage across here?
Sorry, voltage across R2.
Yeah.
Oh.
Yeah, voltage across R2 in manual calculation.
Manual calculation.
What do you think? Not manual calculation, by theoretical lah. We're using voltage divider rule.
It will be 10.
10. Yeah, correct. Looking at the two values of resistor that we have over here, we have R1 1000 and R2 is in the identical values of R1, so R2 also 1000. Logic thinking, we can easily divide the supply voltage by 2. For example, if you want to calculate the voltage value at R1 or R2, just divide 20 divide by 2, because both value are value for resistor is the same. Okay, if we have a look at Nur Izzati's answer, right. For the first question, here we would like to examine the reading of the voltmeter. So the correct answer is 9.5 lah. And here Izzati got correct value of also got 9.5, so it is correct. And the way Izzati find the solution, okay. All right, Izzati. I think your RTH value is, I think, wrong, because you cannot consider RM is actually in the circuit, in the original circuit. So the RTH over here, I think RM parallel with R2 is referring to the RTH, right? No?
No, Doctor.
Oh, okay, RTH is over here. RTH is 1 kilo. Okay. Right. I think over here your answer is correct, and the way you find your solution also, I think, correct, because you are not considering the R2 over here. Okay, by the way, actually, why do you remove R2 over here to find RTH?
Sorry, Doctor.
Why did you remove R2 in order for you to get RTH?
I didn't find the artist. I just use the like normal calculation.
Okay. But here it says that RTH is 1 kilo ohm.
Doktor, yang belah kanan tu confirmation je, belah kiri jawapan. Belah
Okay,
kanan tu saya nak tengok dia punya error sama ke tak.
I see. But I think the one that you wrote in the right hand side is the proper way to answer this question. If this is I think this is not proper lah, on your right hand side over here, RM in parallel with R2. So what's the logic of doing that? So and luckily the answer over here is you get the correct answer, but here is more, your solution is more structure on the right hand side. First you find RTH, and then you find a VTH according to your schematic over here. And I think if we compare our answer, my answer and your answer, the first part over here is a bit different. However, for the second part is we got the same answer lah. And why I'm saying that, the left hand side is not a proper way to solve it, because you cannot justify why do you choose this 20 volts voltage. But on the right hand side, you can justify it by saying that this 20 is coming from the VTH value, or the open circuit value over here. Anyway, you still got a full mark for that, luckily. And for the second part, Rm equals to infinity, your answer is 10 volts. Yes, it's correct. You see here, I mentioned in our class last time, the Rm value must be as big as possible. So here, when we replace our Rm equals to infinity, okay, I didn't get why you use this one, but the answer is correct, 10 volts. But how you managed to do this? Can you explain for me how this happened, this calculation? Why do you choose 1K divided by 1K plus 1K?
Because the RM is infinity, so I thought it is a short circuit. Then I use the voltage divider to get the voltage at AB terminal, which is the same voltage at R2.
Okay. Part of your answer is correct, but I think if you consider RM as a short circuit, that is wrong, because remember that infinity means that the value is very high. So what happens if the value over here is very high? What would happen? For example, if you have, like, let's see, can I have pen over here? Maybe.
0 Ratan?
Yes. Okay, correct. Now you have a circuit like this, and you have another resistor over here. I don't like this one. Oh my goodness. Okay, maybe we should draw it again down here. Okay. And yeah. Oh no. Okay, let's say we have these two branches, yeah. Okay, this is a current. Let's say this is a current. Okay, this is a current, and if this part, okay, if this branch, the resistor value is very high, I believe the current will flow into the first resistor, right? And making this resistor with a circle over here, making it like an open circuit. No current flowing through that branch. So that's what happened over here. If you consider Rm is infinity, means that it should be an open circuit. So an open circuit, yes, correct. This can be neglected. And what happened is that we only have these two resistors connected in series, and you can easily get the value of VAB using this voltage divider rule. Yes, the answer over here is correct, but the concept that you assume over here, I believe, has a bit of a problem. Okay, Izati?
Okay, Doctor.
All right, the answer is correct. And also the error over here, 10 minus 9.5 divided by 10 times 100. So this is also correct.
Doktor,
Okay, yeah.
yang dekat voltmeter tu dia infinite because dia punya current, dia punya resistance is very high, so dia akan choose the less resistance which is dekat R2 lah kan?
Yes, correct. Who asked that question?
Izudin.
Yuzidin. Yes, yes, Yuzidin, correct. The concept should be like that lah, because we consider the RM resistor value over here. Why I always need to keep the two selected? Okay. The concept over here, we consider RM is very high. So the branch that we see over here at our farthest right hand side is considered as open circuit. So the current only flow into this area. And the strategy that Izati did in the solution, I think it's correct. Okay, I would try to get one more solution from the student. Can anyone share your solution? Any
Doctor.
volunteer? Yeah.
Just now, Doctor asked like the right hand side. Why I didn't include the R2 in the RTH, right?
Yes, yes.
Yeah, because yeah, from my understanding, I don't have to include it, but from doctor's way, the thing, so I don't know which one is the right way.
Okay. Both
Yeah.
are right. Okay. The one that you maybe you learned before, that if we want to know what is the total resistance, Thevenin resistance over here, we should remove R2 first, right?
Yes.
We should
Because
remove
we
R2
want,
and find what is the RTH referring to terminal A and B, correct?
yes, yes.
Is that the strategy? Yeah,
Yes.
both strategy are correct. Okay, I would like to later on I will get into that that idea, but at the moment I want one more volunteer that could share his or her answer. Any volunteers? Anyway, I think maybe for question number 2 lah later on, another volunteer, because I really need to clear what Izati asked about. It's about finding the RTH. Okay, if you look my solution, Izati, here and the rest, I consider that this R2 is kept intact. Okay, and I didn't remove R2 over here. And at the end, what I got is that my VTH is a bit differ from what you got in your solution. Can you see the difference? Here, if you look, I keep R2 in the circuit and consider that this A and B terminal extended to an open circuit with open circuit terminal. And I try to find what is the RTH value coming from the terminal A and B. And if we compare my answer and Izati's answer, the value of RTH is a bit different. Okay, the value that Izati got here is 1 kilo ohm, since don't have any resistor R2 over here, and the one that I got over here is 500 ohm, because I have a parallel connected resistor 1000 and 1000 over here, and although the answer over here is a bit differ from what Izati had answered. However, if you look at the next solution, or the next value of VAB, when I connected the RM over here, at the end we will get the same answer. Okay, right. Is it clear, Izati?
Yes, Doctor.
Okay. Any question from the rest about
Doctor,
this? Yes.
I want to confirm my calculation. The left side for question 1A.
Yeah. Yeah.
Yeah. What I did is first I find the parallel resistance between RM and R2, and then for the voltmeter reading, it is the voltage across RM, which is the same as voltage across R2, which is I from the total resistance between R2 and parallel R2 and RM, I use it to get the voltage using voltage divider. That's why I times with 20. I don't know
Yeah,
if
yeah, I
I
understand your solution over here, and
like,
I would say that your answer is correct. If this is a 5-mark question, I would give you 5 marks for this, because it's another way to find what is the value. What is the voltmeter voltage measured value, and but I'm afraid that if 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 this circuit, yeah, maybe you can do that. But if the circuit over here is more complex than this, let's say we have two values of voltages, maybe we have a combination of voltage and current source over here. It's not that easy that you can find like this. You
uh,
need to do something lah, either by using um, mesh analysis, maybe node analysis, perhaps,
mm,
to solve your the answer lah, to solve the value of a voltmeter, measured voltmeter value. But if this is the case, means it's okay, and the answer also correct. And the one that you got at the right hand side also correct. And I would say that I would prefer this solution, because it's more proper way, and you have explanation on every element that you got in your solution. All right, if we discuss about the solution, do you agree with my solution over here, the rest? Okay, the first one is to find RTH, and the second one is to find VTH. I think most of students don't like this idea, because they don't know how to find RTH and also how to find VTH in order to set up a Thevenin equivalent circuit. But believe me, it is very important for you to know how to set up a Thevenin equivalent circuit, because if this is the case, I mean a circuit just consists two resistors, I think you still safe. But if you have a more complex circuit, which consists of multiple voltage source or current source, and also a few others resistors connected in series or parallel, I think you need, by hook or by crook, I think you need to find what is the value of RTH. You need to set up the Thevenin equivalent circuit in order for you to get a simplified version of your original circuit. All right, that's my solution. I will
Doctor,
upload. Yes.
Doctor, I have a question.
Yeah.
About before this, I tell you about the GAB, right? At the before this, yeah, I said when the infinite resistance, that is zero current ground, so
Mm-hmm.
the current will flow at kan dekat RM tu dia akan jadi tinggi kan,
Yes. Yes.
dia akan jadi
Correct.
tinggi. So
Yeah.
dia I punya opinion, dia
Yeah.
takkan lalu dekat situ, dia akan lalu dekat yang 1K. So my solution like Izati, so it's consider true or not my theory? Oh,
Yes. The one that you explained, that you described to me, I think it's 100% correct. If
okay, betul.
RM is infinity, it will be an open circuit element at the RM side, right?
Alright. So saya buat macam tu.
Yeah. For question number B, yes, you need to do that. So if you look at my solution for question number B, okay, welcome. If RM is very high, okay, RM is very high, I just use this formula back. RM, I put it here high and infinity, infinity, and you'll see that you will get the same solution as Izati and the one that asking just now. The value should be 10 volt as well. Okay. And for the measurement error, and normally I think the question over here is not complete. Maybe it's a bit ambiguous. You need to the question actually need to be revised in terms of need to mention of measurement error percentage. However, if you come up with error up until this one, 0.5 volts, I would, considering this is just an exercise or tutorial, I would consider your answer also correct. But if looking at the correct way, if you get a correct question, I mean the precise element that we want to ask, the correct value of error percentage should be the correct value of error should be in a percentage form. So here we have a measurement error percentage should be 5%. And I believe Izati also got 5% over here, but her solution and compared to me is a bit different. But I think the way she answered over here is correct. Okay. Any comment from the others?
Clear.
Okay. Right. Can we proceed with question number 2? Okay. Now, I would comment Izati's answer again, yeah. Maybe. Oh, hi Adam. Baru bangun tidur ke? Anyway, for question number 2, the circuit arrangement, if you look in this question, is somehow the same as we seen in the example that I show in on Monday, except that the value of resistors over here is a bit different. And let's see what exactly have. Okay, this is my answer. Okay, again, I will try to read out the question. Suppose that the components in the circuit shown in figure 3.1a have the following values: R1 330 ohms, R2 1000, R3 1.2 kilo, R4 220 ohm, R5 270 ohm. If the instrument measuring the output voltage across AB has a resistance of 5000 ohm, what is the measurement error caused by the loading effect of this instrument? So here, it's not clearly said that this the RM value. However, it says over here, if the instrument measuring the output voltage across AB has a resistance of 5000 or 5 kilo ohm, means that this 5 kilo ohms referring to the value of RM over here. Okay, understood? Okay, let's see what's Izzati have.
Doktor,
Yeah.
untuk question 2 pun saya buat dua cara. Yang first tu cara saya, lepas tu second page yang bawah tu cara doktor. Saya confused.
Okay, tak apa, tak apa. We compare both answers. Both answers are the same, right?
Ada beza sikit. 0.16 macam tu lah.
4%. Okay. The one the question asks about measurement error, right? Measurement error caused by, okay, the correct answer over here is 4%. Okay, so I think Izzati also got the idea of getting the correct value over here, 4%. But I don't know.
Yes. 3.94 betul kan?
Let's see. Maybe it's correct. Maybe something missing over here. Okay, let's see. All right, now which one is my way and which one is your way? Izzati?
Bawah sekali saya ada tulis cara doktor bulat tu.
Oh, this one is my way.
Yes.
And what happened to this measurement error? Which one is mine? Which one is yours?
Both is doctors, but masa lecture yang bawah tu, yang 4 tu dia tak ada kat lecture note tapi doktor terangkan.
Okay.
Nota saya tak ingat mana satu.
Since this is my way, I think both are correct. It's okay. Sorry. Let's see what Izzati have in the first part.
Ya, doktor. Alright, saya pun Dr. Wei juga.
Okay. Memang jalan yang lurus lah, Siratul Mustaqim. Alright, anyway, I think maybe you miss something in this calculation. Let's see. Alright, if you look at the one that Izzati have over here, she considered that this R5 is removed. Is it correct, Izzati?
Yes, okay.
Okay. Remove. And later on, this is 130. This is correct. Okay, maybe we put some notes over here. This is correct because these two resistors is considered in series, and later on he parallel these two together, means that I don't know what's the value of the parallel resistor. Suppose the value should be 630, and later on, okay, I think this also correct because later on she series with this 220 ohms resistor, so consider this is also correct. Okay, now finding the RTH. Now RTH, I think this is correct, and we have VTH over here and RTH. Please don't draw like this here. Please properly draw lah. Okay, now we have 270, and we have RTH, and also we have 5 kilo ohm over here. And what you did was 270 in parallel with 5 kilo. I believe this calculation should be correct. I hope. And later on, from here, you use this 255. Okay, you use voltage divider rule over here, right? This is voltage divider rule. And I don't know the correct answer, but I think this should be okay as well. And later on, I think this is not necessary. Later on, you use this 0.23 VTH minus 0.24. Where do you get this one?
The one that you pangkal is I consider the
Oh, okay, all right. Oh, okay. Okay. All right. Means that this is also useful later on. And you using considering Rm is infinity, okay. And if Rm is infinity, means that we only have this 270. No. If Rm is infinity, okay, what happened if this is very high, this branch is very high, and we parallel with something which is small? What happened over here? Can we test like this? Right. Okay, we have two resistors. Let's say this is 1 ohm, this is 1 kilo ohm. One kilo. Okay, can you solve this one? What is the total resistance? What's the value of the total resistance?
0.999.
0.999 what?
Ohm.
0.999 ohm. Is it? I'm looking for 1000. Oh, yes. 1000 times 1 divided by 1001. Yeah. So, in other words, we would say that if Rm is infinity, meaning that this is considered as R 270 ohm. I think this one is correct. Okay. And since you're using voltage divider rule, meaning that this is also correct, and at the end you are using the same method that you used before, 0.23 minus 0.24 divided by 0.24. 0.23 minus 0.24 divided by 0.24. 0.0416. Okay, I would consider this one also correct. Okay. Boleh Zati?
Okay, Doctor.
And of course, this one is also correct, but I don't know about this one. Maybe it's due to just decimal places problem, decimal points problem. And also this one also due to decimal point problem as well. If you take all the decimal points, maybe you will get the same answer as me. Anyway, I will show you my solution here. All right, here. Looking at my solution, here I put it as step by step. Can you all follow the style of my solution in future to make it more clearer for me to give you marks? Okay.
Can Doctor.
Later on lah tulis pakai kaki.
Circle
Jangan
and
tulis
then
pakai
the
calculation.
equation, right?
Yeah. Jangan tulis pakai kaki Tulis pakai tangan.
Apa yang tulis buruk tu?
Tak buruk tak apa, janji kalau jawapannya betul. Kalau salah tu yang susah saya nak bagi markah sebab terlampau menarik sangat tulisannya kan. Anyway, if you look at my strategy, I always use the same strategy that I have previously. So now I just expand this terminal a little bit longer and also consider this R5 in my RTH calculation. And later on, my RTH calculation, I think same as what Izzati had presented, only that she presented up until this part. Okay, presented up until this part, but I extend or I have another value of RTH, which is 205 over here. And this is due to resistor RC in parallel with R5. Okay, that's for RTH, and we don't need to calculate the value of VTH or the value of voltage in our equivalent circuit because the value of voltage in our original circuit is not given. So there's no way for us to calculate the value of voltage over there. But you can always draw the Thevenin equivalent circuits with a symbol of your voltage, Thevenin voltage, as well as your Thevenin resistance. And if you look at what I have over here, if the voltmeter is connected and I have RTH and RM connected in series, so easy for me to calculate what is the voltage across this voltmeter, where EM, where I believe EM considered as my voltmeter voltage, can be calculated using voltage divider rule. I take Rm divided by Rm plus RTH and times EO, or in this case EO equals to VTH and equals to ES. And I will get my EM value as 0.96 of EO. And if I would like to determine what is the measurement error, I would use this strategy, EO minus 0.96 EO, or EO minus EM, and I will get the measurement error over here. But again, it's in terms of EO. And for the measurement error percentage or the loading effect, basically loading effect will be is given by a percentage value. So loading effect is just multiply your measurement error with 100%, or the one that Izzati showed in her solution. Both I will accept. And again, Izzati, don't think that your answer over here is a bit differ from me, meaning that your answer is incorrect, because I will try to get where the mistake, or maybe not mistake lah, maybe the way you give your solution a bit different compared to my solution. So don't worry about that. As long as you can give me your working, I try to find how, I try to help how I can give you marks on that. And if you look at your solution, although the value over here is not the same as what I have, I would consider this one also is a full mark. Okay. Anyone else want to share answers over here, or any question from others? You clear with the solution?
Clear Doktor.
Okay. Adam, masuk lambat. Okay gitu. Adam.
Okey Doktor, okey.
Okay. Kau gimana Adam?
Ada Doktor.
Anyway, I think that's all for today. As usual, I think